The blue line here indicates the tangent, and there is a yellow line, and this is the normal that we're concerned with. So to find this equation of the normal, we will need to find the coordinate of the point, this point here in white. So first of all, we need the coordinate, and the coordinate can be seen from that function. It's obviously at x is equal to -1 because we're told that it is. So let's just draw a dotted line here and say that that is -1. Now the other part of the coordinate here will be the value of y, and that means that, so we've got at f at -1, therefore is 2 minus x cubed, and that is 2 minus -1 all cubed, which is equal to 2 plus 1, which is equal to 3. So the coordinate at this point here is 3. So we may say now that the coordinate is -1 and 3. The second thing that we've got to be looking for is the gradient or the slope. To find the gradient and the slope, you're going to have to find the derivative of that function. So our function is fx 2 minus x cubed. And the derivative of that function can easily be found through -3x squared. And that is the derivative of that function at any point. And the point we're interested in is -1. So let's look at the derivative at x equals to -1. We're looking for the slope. Slope is -1 is -3 -1, substitute for x, and that is going to give us -3. So the slope, which we will identify, use m, is -3. Important. This is the slope of the gradient. This is the slope of tangent to the function. But we want to find the equation of the normal. So we need to look for the slope of the normal. The slope of the normal, which is indicated by the yellow line on the graph. We can find the slope of the normal by finding the negative reciprocal of the normal slope. So let's say our slope is -3. Now to find the normal, the negative reciprocal, write it down like this. M is equal to -3 over 1, because now we can reverse that up there, and with the negative reciprocal will now become 1 over 3. Well, that's the definition of a negative reciprocal. So now we can say that our new slope, well, let's write it in red, our new slope of slope of normal, is equal to 1/3. We already know what the coordinates are. The coordinates are -1, 3, which we, substituting all this into our equation, y minus y1 equals mx minus x1. y minus 3 equals to a third x minus 1, and just simplifying this, we'll find y is equal to a third x plus 1 and add the 3 on that side. Simplify it a little bit more and we get a third x plus 1/3 plus 3. We want to simplify it by making sure that we add these together. Okay, putting them under the same denominator, we will get a third x plus a third plus 3 times 3 is a 9 over 3. That's easy to add, and we finally end up getting 10 over 3, and that is our equation of the normal. Equation of the normal. That's it. Where does this equation intercept the y-intercept? The y-intercept can be found by substituting x equals 0 into this equation. So if I substitute x is equal to 0, my equation is a third, and let's say I substitute 0 in here and add 10 over 3. It is obvious that the first term is actually 0, and the value for that is 10 over 3. What if we wanted to find the equation of the normal at x is equal to a? Okay, we've drawn that graph again, and this time x is equal to a. That's an abstract, any number whatsoever. Well, if x is equal to 1, then the function at a is going to be 2 minus a cubed. So our coordinates will now be a and 2 minus a cubed. All right, we now need to look for the gradient or the slope. So we've already found the slope here at any point. There it is. Okay. So in that case, we can now find what that slope is at a. At a, our slope will be minus 3a squared. That is the slope of the gradient tangent, or this is the slope of the tangent. Once again, we now need to change it because this is the slope minus 3a squared. We want to change it into this for the slope of the normal. Let's just put this over 1, and then the slope of the normal is going to be the reciprocal, the negative reciprocal. So the slope is going to be 1 over 3a squared. The negative disappears, and we're just getting the inverse of that. So now we can combine all that into our equation. Y minus y1 equals mx minus x1. Okay, so that's y minus 2 minus a3. Now, if you do not put the brackets in here, you're going to find it a completely wrong answer. So then we've got the normal, which is 1 over 3a squared, and x minus 2a. That's the value. Now we need to simplify it. Y, and I will move this. This is the way I like to work through it. So I will add that 2 minus a onto this side. Leaving it in this form is just as good. Don't think we need to go any further. We can just say that that is it. It's quite big. If we wanted to find where it intercepts the y-axis, we will need to ask what is the value when x is equal to 0. So y is equal to 1 over 3a squared, and this is where the x comes in, 0 minus a plus 2 minus a cubed. Okay, so we can do it a little bit further. So that means that, and I'm just simplifying it further up here, that's 2 minus a cubed. This whole thing becomes 0. So all we're left with is a over a squared, and we can also cancel a and an a over here, which means we just have minus 1 over 3a plus 2 minus a cubed. It might be nicer just to put it all integrated into 1, which means let's put it all under 3a. If we put it all under 3a, then this becomes 2. We need to also multiply that by 3a. Okay, and then we put a cubed, and we also must multiply that by 3a. So this can then be further minus 1 plus 6a and minus 3a to the 4th over 3a. Not too sure that that makes much of a difference, but it's just written in one other way. So when x is equal to 0, this is where it intercepts. So we really looked at 2 parts here. One is the equation of the normal at a particular point called x is equal to minus 1. And in the second part, we looked at it, what the equation of the normal is at an x is equal to a, just an abstract part.